Okay, this colligative properties is just building on the basics that you should hopefully are comfortable with. So if not, make sure you're comfortable with those calculations before you attempt these because there's just a small little change. And so we have the same four properties. And so I'm going to start with boiling point and then come back to Raoult's law first. So boiling point, it is the exact same except for we add this I function in here in front. And so it's just the number of ions for it. And so the same type of property would happen. Here we have benzene, so I would be 1. If we had sodium chloride, now then when it dissolves, it would dissociate into sodium and chloride ions. And so therefore we would have a molal of the sodium, a molal of the chloride. So that's why I would become 2. All right. So the you get the change in boiling point, and you have the same. So first finding that change, and then second is finding the new boiling point of the solution. So that is exactly the same. The only difference is the multiplicative property of it ionizing. So we have the same thing in the freezing point, that the TF is equal to KFM, and so we just added I in there, and I don't believe there's, sorry, scroll down. Now urea, same thing, talks about it. I'll have another one though. All right. And so that's the only difference. You get the delta TF, and now you can find the freezing point. Osmotic pressure, it's the exact same. And here they do have like we talked about last time, I didn't scroll through. If you come down, you look at the sodium chloride, here now it shows it because 1 mole of sodium chloride produces 2 moles of particles. Then we simply take that 2 times that concentration to give it there. All right, so that's the Van Hoff factor we have there. So boiling, freezing, and osmotic pressure, we just multiply by I. Raoult's law is a little special. And so we have the same type thing, but here you don't put the I in there. Why? Because you're not looking at the mole fraction of the solute, you're looking at the solvent. And so if we scroll down here, the bottom, it'll explain it. So the same thing happens. You get 1 mole of solid salt, gives you 2 moles of ions. But how it's factored in, though, you have to jump further down. And so non-electrolyte, and then here, example 2b, electrolyte. And it talks about how you would factor that in for calcium chloride. And so what we get then is we get more moles of those solutes. And so you get the I down here. So you have 0.45 moles of the calcium chloride, but when it dissociates, then you would have 3 times that. So on the bottom, it's adding it, but you could easily do I times the moles and get that number. All right. So I times 0.45 gives you the total here for these. That's how I would do it. And again, because it's mole fraction on the total moles, you have the moles of water there. All right. So just again, baby steps, know the basic colligative properties, and then for dealing with electrolytes, then boiling, freezing, and osmotic is really straightforward. Uh, Vapor pressure lowering, then it's a little more work.